Think of a predator so fierce it could hunt prey larger than today's elephants, even with a broken leg or cracked rib. The Smilodon, or saber-toothed cat, lived with this level of resilience during the Ice Age. Fossils from the Brea tar pits reveal healed injuries, raising questions about how they survived. Delving into their lives, we may uncover surprising complexities in their survival strategies. Imagine a world where cats ruled supreme, not as adorable house pets, but as apex predators capable of taking down mammoths. This was the reality during the Pleistocene epoch, when Smilodon, the saber-toothed cat, reigned as one of the most formidable predators of its time. The evolution of this iconic Ice Age hunter is a tale of adaptation and specialization spanning millions of years. The story of Smilodon begins with a lineage of carnivores that had already begun to develop elongated canine teeth. Early saber-toothed cats like Machairodus and Homotherium set the stage for Smilodon's eventual domination. As the climate fluctuated and ecosystems shifted, these prehistoric felines faced immense evolutionary pressure to adapt or perish. The Pleistocene brought about dramatic environmental changes. Vast grasslands expanded, and large herbivores like mammoths, ground sloths, and bison flourished. This new landscape presented both challenges and opportunities for predators. The abundance of large prey animals meant potential for a feast, but catching and killing these massive beasts required specialized adaptations. Smilodon evolved to meet these challenges, developing a unique set of features that set it apart from modern big cats. Its muscular build was more robust than that of modern lions or tigers, with powerful forelimbs and a short tail, suggesting a focus on strength over speed. This physique was perfect for grappling with large, strong prey. The cat's skull structure underwent significant modifications to accommodate its famous saber teeth. Smilodon's jaw could open to an incredible 120 degrees, nearly twice that of modern lions, allowing it to make effective use of its elongated canines, which could grow up to 11 inches in length. These adaptations made Smilodon the ultimate Ice Age predator, capable of subduing large prey and delivering fatal blows with precision. Smilodon's hunting strategy differed significantly from that of modern big cats. Rather than relying on speed and endurance, it likely employed ambush tactics. Its powerful build allowed it to pounce on unsuspecting prey, using its strong forelimbs to wrestle the animal to the ground. Once subdued, Smilodon's saber teeth came into play as precision instruments, used to deliver a fatal bite to the throat or belly of the prey, quickly dispatching even large animals. This combination of strength, specialized dentition, and unique hunting strategy allowed Smilodon to take down prey much larger than itself, from bison and camels to juvenile mammoths. In the competitive world of the Pleistocene, where numerous large predators vied for resources, Smilodon carved out a niche as one of the most successful hunters of its time. However, Smilodon's specialized features came at a cost. The very adaptations that made it such an effective predator also made it vulnerable to changes in its environment. As we'll explore in the next section, Smilodon's reign as the king of Ice Age predators was both impressive and precarious, setting the stage for a dramatic saga of survival and, ultimately, extinction. While Smilodon's extinction suggests vulnerability, its physical adaptations reveal a formidable predator. This Ice Age cat possessed a unique combination of strength and precision that made it a highly effective hunter. Smilodon's body was a marvel of evolutionary engineering. Its muscular structure far surpassed that of modern felines, with forelimbs approximately 20% thicker than expected for a cat of its size. This extra muscle mass provided Smilodon with strength that exceeded even larger cats like the American lion, allowing it to subdue prey that dwarfed it in size. Despite its robust build, Smilodon was surprisingly agile. Its elongated heel bone suggests it could have leapt even higher than modern lions, which have been observed clearing heights of 15 feet. This combination of power and agility made Smilodon a truly formidable predator. Smilodon's skull was a fortress of bone and muscle, built to withstand the forces involved in tackling large prey. Its short, broad muzzle and deep, widely arched cheekbones provided structural support, while a prominent sagittal crest on top of the skull offered attachment points for powerful jaw muscles. Contrary to popular belief, Smilodon's elongated canines were not suited for biting into bone. Instead, they were precision instruments used in conjunction with its powerful build and unique jaw structure. Biomechanical studies suggest that Smilodon likely used its saber teeth to deliver deep, slashing bites to the neck or belly of its prey, causing severe blood loss. This method stands in stark contrast to the suffocating bite employed by modern big cats. To avoid damaging its fragile canines, Smilodon first had to subdue its prey using its immense strength, pinning the animal down before delivering the fatal bite. Once the prey was dispatched, Smilodon's carnassial teeth came into play. Located on the sides of the mouth, these teeth acted like built-in steak knives, allowing Smilodon to shear through flesh while its canines remained clear of the bone. This combination of adaptations, robust build, powerful limbs, extreme jaw gape, and specialized dentition made Smilodon uniquely suited to hunting the megafauna of the Ice Age. Its body was a perfect balance of strength and precision, allowing it to take down prey much larger than itself with remarkable efficiency. While Smilodon's teeth were its most famous feature, its hunting strategy was far more complex than a simple bite. The way Smilodon used its incredible adaptations to hunt was a sophisticated interplay of power and precision, challenging our perceptions of these ancient predators. Smilodon's hunting technique was far from graceful, defying the Hollywood image of a sleek, agile predator. This ancient cat employed a strategy more akin to professional wrestling than ballet, relying on raw power and precision to overpower its prey. The hunting behavior of Smilodon has been a subject of intense debate among paleontologists for decades. Some argue it was a solitary hunter, similar to modern leopards and jaguars, while others propose it hunted in packs like lions or wolves. The high concentration of Smilodon fossils at the Brea tar pits, along with evidence of healed injuries, suggests these cats may have lived and hunted in groups. However, critics argue that this concentration could simply be the result of many individual hunting failures over time, rather than evidence of social behavior. Regardless of its social structure, Smilodon's hunting strategy was based on ambush rather than pursuit. Its muscular build and relatively short legs made it better suited for short, powerful bursts of activity than prolonged chases. This powerful physique allowed Smilodon to quickly overpower its prey, using its strength to wrestle larger animals to the ground. Recent biomechanical studies have revealed a hunting method unlike anything seen in modern predators. Instead of using its elongated canines for slashing or stabbing, Smilodon likely employed a canine shear bite technique. After subduing its prey, Smilodon would take advantage of its extreme jaw gape to position its saber teeth around the prey's throat. With a precise, powerful bite, it would drive its canines deep into the flesh, severing major blood vessels and causing rapid blood loss. This method would have been particularly effective against the thick-skinned Megafauna of the Pleistocene. This specialized killing technique required not only immense physical strength, but also careful coordination to avoid damaging the relatively fragile saber teeth. The evolution of such a unique hunting method speaks to the intense evolutionary pressures of Smilodon's environment and the fierce competition for resources during the Ice Age. Smilodon's combination of strength, stealth, and specialized dentition made it one of the most successful hunters of its time. However, it wasn't the only predator stalking the Pleistocene landscape. As we'll explore next, this saber-toothed cat had to navigate a world filled with formidable competitors and ever-present dangers. The Pleistocene epoch was a time of extremes, with massive ice sheets sculpting the landscape and megafauna roaming vast grasslands. In this world of giants, Smilodon carved out its niche as an apex predator, but its reign was far from unchallenged. The ecosystem teemed with formidable competitors, each vying for their share of the prey. Among Smilodon's rivals were the American lion, dire wolves, and the intimidating short-faced bear, a behemoth that could outweigh even the largest saber-toothed cat. Despite fierce competition, Smilodon proved remarkably adaptable. Smilodon thrived in diverse habitats across North and South America, from frigid tundra to temperate grasslands. Survival, however, came at a cost. The fossil record tells a story of hardship and injury that would make even the toughest modern predators wince. The Brea tar pits in California, home to over 166,000 Smilodon bones, provide a window into the brutal life of these ancient cats. Many fossils show signs of healed injuries, including trauma to the sternum and other bones, likely sustained during violent encounters with prey or competitors. Some Smilodon fossils even show evidence of severe conditions like ankylosing spondylitis, a type of arthritis that can fuse spinal vertebrae, and hyperostosis, an abnormal growth of bone. How did Smilodon manage to survive with such debilitating injuries? The answer may lie in its hunting strategy. Unlike modern big cats that rely on speed and agility, Smilodon was built for power. Its ambush hunting style, while risky, allowed it to take down large prey quickly and efficiently. This method, combined with Smilodon's incredible strength, may have enabled injured individuals to continue hunting even with reduced mobility. The high frequency of healed injuries in Smilodon fossils suggests a level of resilience that's hard to fathom. These cats weren't merely surviving, they were thriving in the face of constant danger and competition. Their unique adaptations, from their powerful build to their specialized dentition, gave them an edge in various habitats, allowing them to maintain their status as apex predators despite the challenges they faced. Smilodon's story is one of survival against the odds, a testament to the incredible adaptability of life in the face of harsh conditions. But their reign wasn't limited to a single continent. These formidable predators embarked on an epic journey that would see them conquer 2 continents, facing new challenges and adapting to diverse environments along the way. Smilodon's journey across the Americas is a story of extraordinary adaptation. Starting around 3 million years ago during the Great American Interchange, this fierce predator crossed the Isthmus of Panama, leaving its North American origin to explore the unfamiliar terrains of South America. Smilodon gracilis, the earliest saber-toothed cat, braved diverse environments: Central American rainforests, expansive pampas grasslands, and the rugged Andes, each new setting demanding rapid evolutionary changes. As Smilodon ventured south, it evolved into distinct forms. In North America, Smilodon fatalis thrived in dense forests, ideal for ambush hunting. But in South America, where it encountered open plains and thicker vegetation, a larger and more robust species emerged, Smilodon populator. This subspecies grew to be one of the largest cats in history, reaching weights of over 400 kilograms. Isotopic analysis of Smilodon remains reveals dietary shifts between populations. While North American Smilodon likely preyed on bison, camels, and horses, South American Smilodon had to adapt to unfamiliar prey like giant ground sloths and glyptodonts, armored giants resembling small cars. Hunting these novel, well-protected animals required refined strategies. Smilodon likely had to target specific vulnerable areas on these bulky prey. As apex predators, Smilodons influenced ecosystems profoundly. Their presence had cascading effects, shaping prey behavior, impacting vegetation, and possibly even altering landscapes in a phenomenon known as a trophic cascade. Smilodon's dominance, from Canada's icy tundra to Brazil's tropical forests, illustrates its incredible adaptability, which was essential for its long reign through the Pleistocene epoch. But Smilodon's story goes beyond its predatory dominance. Evidence of healed injuries and social behaviors suggests complex relationships within groups, challenging our assumptions about ancient predators and hinting at cooperative dynamics. These Ice Age titans weren't simply relentless hunters. They coexisted in ways that reveal rich layers to their survival strategies, offering new insights into their unique role in prehistoric ecosystems. Recent evidence suggests Smilodon might have had more in common with lions than previously thought, particularly regarding social behavior. For decades, paleontologists have debated whether these iconic Ice Age predators lived solitary lives like many modern big cats or formed social groups more akin to lions. This question has profound implications for our understanding of Smilodon's hunting strategies, survival rates, and overall ecology. The debate over Smilodon's social behavior has been fueled by conflicting interpretations of fossil evidence. Some researchers point to the abundance of Smilodon remains found at sites like the Brea tar pits in California, arguing that the high concentration of fossils suggests these predators may have lived and hunted in groups. This interpretation gains further support from the numerous healed injuries found on Smilodon skeletons, which would have been potentially fatal for a solitary hunter. However, other scientists caution against drawing too many conclusions from predator trap sites, arguing that the concentration of remains could simply be the result of many individual hunting failures over time. Studies of sexual dimorphism in Smilodon fossils have added another layer to this debate. Unlike modern lions, where males are significantly larger due to competition for mates, Smilodon fossils show little size difference between males and females. This lack of pronounced sexual dimorphism could indicate a different social structure than what we see in modern social cats, challenging simple comparisons to lion prides. As the debate continues, new research methods are shedding light on Smilodon's potential social behavior. Comparative studies with modern social predators, such as lions and spotted hyenas, suggest that social living may have provided advantages in hunting and survival for Smilodon. The ability to share food resources among group members, for example, could have been particularly beneficial when tackling large prey. While a definitive answer remains elusive, the current consensus leans towards Smilodon having some degree of social behavior, albeit potentially different from what we see in modern big cats. This understanding has profound implications for how we view these ancient predators. Rather than solitary killing machines, we might instead imagine Smilodon as complex social animals, capable of cooperation and possibly even care for injured group members. Understanding Smilodon's social structure gives us new insight into its most famous feature. The potential for social behavior adds another dimension to our understanding of how Smilodon used its iconic saber teeth. These fearsome weapons were not just tools for killing, but may have played a crucial role in Smilodon's social interactions and survival strategies. As we continue to uncover evidence about Smilodon's behavior, we gain a more complete picture of this fascinating prehistoric predator and its place in the Ice Age ecosystem. When it comes to Smilodon's teeth, their size and fragility tell a complex story of evolutionary adaptation. These massive canines, growing up to 11 inches in length, were far more delicate than the robust teeth of modern big cats. This paradox of seemingly impractical yet highly effective weapons has fascinated scientists for years, revealing a remarkable balance of specialized anatomy and precise hunting techniques that made Smilodon one of the most successful carnivores of the Pleistocene epoch. The development of elongated canines wasn't unique to Smilodon. Saber-like teeth evolved independently in several lineages of carnivorous mammals over millions of years. However, Smilodon took this adaptation to the extreme, resulting in a surprisingly weak bite force for a predator of its size. Studies have shown that Smilodon could only generate a bite force of about 1,000 newtons, 4 times weaker than that of a modern lion. Fossil evidence reveals that many Smilodon specimens exhibit signs of dental injuries, indicating that their high-risk stabbing bites often resulted in broken teeth, particularly when engaging with large prey. This vulnerability meant that Smilodon had to be extremely careful in how it used its primary weapons, further emphasizing the importance of its overall hunting strategy. The true purpose and advantages of Smilodon's saber teeth become clear when considered as part of the predator's entire hunting approach. These weren't just weapons, but precision instruments that, when used correctly, made Smilodon one of the most efficient killers of the Ice Age. Their elongated shape allowed for deep, fatal wounds, while their relative fragility encouraged a hunting style that minimized prolonged struggles with prey. However, even the most perfect adaptation has its limits. The very specialization that made Smilodon so successful also left it vulnerable to changes in its environment. The story of Smilodon's teeth serves as both an example of evolutionary triumph and a cautionary tale about the risks of overspecialization in a changing world. For over 20 million years, Smilodon reigned as one of the Ice Age's apex predators. Yet, in a geological instant, it vanished. This extinction has puzzled paleontologists for decades, prompting various theories to explain the downfall of such a resilient and specialized hunter. The most compelling explanation focuses on Smilodon's highly specialized adaptations. Its robust build, powerful forelimbs, and iconic saber teeth were perfectly suited for hunting large prey. However, as the climate warmed at the end of the Pleistocene epoch, these specializations became a liability. The changing environment led to a decline in Megafauna, Smilodon's primary food source. Vast grasslands that supported large herbivores shrank, replaced by expanding forests. This shift in vegetation and prey availability put immense pressure on Smilodon populations, forcing them to adapt to new hunting strategies or face starvation. Climate change, however, was not the sole factor in Smilodon's demise. The arrival of early humans in the Americas introduced a new competitor, with advanced hunting techniques and tools. While direct evidence of human predation on Smilodon is scarce, the competition for resources and potential impact on prey populations likely further stressed these already vulnerable predators. Recent research has provided more precise data on the timeline of Smilodon's extinction. The youngest remains of Smilodon fatalis, the North American species, date back to around 13,000 years ago. Smilodon populator, the larger South American species, persisted until about 11,000 years ago. This staggered pattern suggests that local conditions influenced how long Smilodon populations could withstand the changing world. The current scientific consensus points to a combination of factors leading to Smilodon's extinction. Climate change altered the landscape and reduced prey availability, while Smilodon's specialized adaptations limited its ability to rapidly evolve new hunting strategies. The potential competition from human hunters may have been the final factor pushing these magnificent predators past the point of no return. Smilodon's story serves as a poignant reminder of the fragility of even the most successful species in the face of rapid environmental change. It highlights the delicate balance between specialization and adaptability in evolution, and the far-reaching consequences of ecosystem disruption. As we continue to uncover more about this iconic predator's life and demise, we gain valuable insights into the complex dynamics of prehistoric ecosystems and the challenges facing modern species in our changing world. Imagine holding a tooth that hasn't seen daylight in over 10,000 years, revealing secrets about an entire species' way of life. This is the reality as new technologies unlock the hidden stories within Smilodon fossils, offering unexpected truths about this iconic Ice Age predator. The study of Smilodon has evolved significantly since the first fossils were discovered in the early 19th century. Initially misidentified as a type of hyena, decades of research were required to piece together an accurate picture of this ancient cat. Today, each new fossil discovery adds another piece to the complex puzzle of Smilodon's life and its ecosystem. Interpreting these ancient remains presents unique challenges. Fossils are often fragmentary, with only a few bones or teeth surviving millennia. Scientists employ a combination of comparative anatomy, statistical analysis, and informed speculation to reconstruct Smilodon's appearance and behavior from these limited clues. Certain fossil sites have proven invaluable in our quest to understand Smilodon. In Peru, the Talara site has yielded numerous fossils of Smilodon populator, the larger South American species, helping scientists understand how Smilodon adapted to different environments across two continents. Recent technological advancements have revolutionized Smilodon research. CT scanning and 3D modeling allow examination of internal structures without damaging fossils, providing new insights into Smilodon's brain, sensory capabilities, and saber-tooth development. Isotope analysis of teeth and bones reveals diet and habitat information, challenging assumptions about Smilodon's hunting behavior across regions and time periods. The discovery of Rhizosmilodon in Florida has provided new context for saber-toothed cat evolution, suggesting that both Smilodon and Meganterion may have split from a common North American ancestor. This finding rewrites our understanding of saber-tooth evolution. A groundbreaking study on microscopic wear patterns on Smilodon teeth has challenged long-held assumptions about its hunting technique. By comparing these patterns to those of modern carnivores with known diets, researchers have uncovered evidence suggesting a more precise and less violent killing method than previously thought. These recent findings have dramatically altered our view of Smilodon. Far from being a simple, brutish predator, Smilodon is emerging as a complex, highly adapted animal with sophisticated hunting strategies and social behaviors. Our understanding of its evolution, ecology, and extinction is becoming increasingly nuanced, painting a picture of a remarkable creature that was both powerful and vulnerable. As we piece together Smilodon's past, we're also uncovering surprising connections to the present. The story of this ancient predator offers a window into prehistory and reflects our own relationship with the natural world and the consequences of environmental change. Smilodon's legacy reaches far beyond its Ice Age extinction, shaping our understanding of evolution, extinction, and ecosystems. As a model predator, Smilodon offers key insights into how species respond to environmental shifts, valuable lessons as we face today's ecological challenges. Smilodon's specialized traits, its massive frame and saber teeth, highlight natural selection's power and the risks of overspecialization. While these features made it a formidable hunter, they also left it vulnerable to rapid environmental changes, sparking debates on species revival. Some scientists see de-extinction as a way to restore ecosystems, while others raise ethical concerns about potential disruptions. Research on Smilodon has also impacted modern conservation, especially for big cats. By studying its adaptations to prey and habitat shifts, scientists gain insights that help predict how today's predators might respond to habitat loss and climate change. This knowledge is crucial for creating strategies to protect endangered species like tigers and lions. Smilodon's impact isn't confined to science. It captivates the public through museum exhibits and documentaries, nurturing interest in paleontology and conservation. This widespread fascination strengthens public understanding of evolution and the importance of biodiversity. Additionally, Smilodon research drives advancements in diverse fields. Biomechanical studies of its hunting techniques inspire the design of better surgical tools, while analyses of its bones inform treatments for osteoporosis. Even its extinction helps refine climate models, aiding scientists in forecasting climate change effects on modern species. Smilodon's story serves as both a warning and an inspiration. It reminds us of the planet's once vast diversity and how environmental changes can challenge even the most resilient species. By studying Smilodon and other extinct animals, we uncover critical insights into evolution, ecology, and extinction, lessons essential for preserving Earth's biodiversity for future generations. Smilodon's story serves as a powerful reminder of nature's delicate balance and the risks of rapid change. This iconic predator, once perfectly adapted, ultimately fell to shifts in climate and prey. Studying Smilodon and other prehistoric species helps scientists understand ecosystem dynamics and informs modern conservation efforts. Through ongoing research, we gain deeper insights into evolution and adaptation, essential for protecting Earth's biodiversity. Smilodon's legacy endures, inspiring curiosity and underscoring the importance of learning from the past to help preserve our planet's future.